Hello and welcome to, day 2 and the final day of this mini Unit 12. We're going to take what you guys covered the past few days and we are going to now solve trig equations. This is something you'll see next year in pre-calc, so that's why we kind of wanted to give you a little bit of a preview of it so that you had kind of a basis before you start pre-calc next year. All right, so solving trig equations, we aren't going to do too complicated of ones, but when you solve a trig equations, what that means is you are finding the measure of the angle or angles in a specified interval that make the trig equation true. So we are going to be actually solving for the angle measures, usually in degrees, but it could also be in radians, and we'll talk about that, I believe, on the last example today. So when you're solving trig equations, you want to treat the trig function as if it's the variable that you're solving for. So we actually might use a method of substitution for some of the more complicated looking ones. So if the trig function, so whether it's sine or cosine or tangent, we're going to think of that as like x. So when you solve the trig function by any means, we might just use basic solving, like additive inverse to the other side, divide and isolate. We might have to use the quadratic formula some of the times. We might have to factor. We might have to do triangle method, complete the square. And sometimes, like I said, you might want to substitute x for the trig function just to make it a little bit more palatable for our solving methods. All right, so after we isolate the variable or isolate your trig function, the next step is finding the reference angle. So remember, finding the reference angle, sometimes we have to use inverse trig. So in your calculator, that typically means you're going to do like second sine or second cosine to be able to find the angle measure. So we're going to find our reference angle. Then we have to decide what quadrant we want that matches our variable. Remember, our AST chart helps us determine that. ASTC. The A stands for all, the S stands for only when sine is positive, T is when tan is positive, and C is when cosine is positive. So sometimes we're only going to want the positive answer for sine. Sometimes we'll want positive and negative answers for sine, and that would mean we have 4 separate answers. So first we have to find the reference angle, what quadrant, and then we have to determine what our actual angle measures are in the correct quadrants that they fall in. So we're going to use that bow tie method. So we have quadrant 1, 2, 3, 4, and we use our reference angles in each of the 4 quadrants, and it kind of makes that bow tie shape. All right, so let's get going here. Let's see what happens. All right, we're going to want to make sure our calculator is in degree mode. So if you need a second to do that, definitely make sure your calculator is in degree. All right, so if you're in degree mode, we are going to be solving for only angles that fall between 0 and 360 degrees, and we're going to be rounding to the nearest degree. So if we get something that does not come out to be an exact angle, we're just going to round it. All right, so number 1. I'm going to leave this in terms of cosine, but if it helps you to say something like, let x equal cosine of theta, you could, if you wanted to, rewrite this looking like that. And if that looks way easier to you, feel free to do that. But I'm going to leave the cosine in there. So if I want to solve for cosine of theta, I would add the 1 to the other side, just like you would here. I get 2 cosine of the angle is equal to 1. Divide by 2, divide by 2. So I get cosine of some angle is equal to a positive 1/2. All right, so the fact that this is positive, okay, the fact that it solves to be a positive 1/2, that means I'm going to use my ASTC chart and determine that cosine is positive in quadrant 1 and cosine is positive in quadrant 4. So which quadrants I'm going to look at is quadrants 1 and quadrants 4 because this value is positive. But 1/2 is not your reference angle. To determine your reference angle, what you're going to do is you're going to take out your calculator, or, because 1/2 is one of our nice values that we know from our 1, 2, 3 and a 3, 2, 1 charts, but I'm going to do this. Inverse cosine of 1/2. Oh, silly me. I didn't put my calculator in degrees, even though I just got done telling you to do that. Well, at least now you know that you would be wrong. There you go. All right, cosine is equal to 1/2 at a measure of 60 degrees. So our reference angle is 60 degrees. So now that we know which quadrants to look in and what our reference angle is, I'm going to kind of draw this. I know I need to be in quadrant 1 and quadrant 4. If I draw a 60-degree angle in quadrant 1, that is 60 degrees. But if I draw a 60-degree angle in quadrant 4, technically, to get there, I'm going all the way around and stopping here. So one of my answers is 60 degrees because that falls in quadrant 1. But the answer that falls in quadrant 4 is 300 degrees. There are 2 answers for this question. All right, so theta could equal 60 or 300 degrees. Both of them fall in our interval that we specified. All right, let's try our second example. I'm going to switch my color so you can kind of see which one was for what. So number 2, we have 4 sine squared of x minus 2 equals 0. So if you want to say, let sine of x represent y or x or whatever letter you want. Actually, I'm going to use x just because I think you guys are going to feel better about that. So 4x squared minus 2 equals 0. So I let sine of x equal x. So when I replace it and I want to solve, I'm just going to add 2 to the other side, just like on the last question. Ignore the lawnmower if you can hear it in the background. Divide by 4. So I have x squared is equal to 1/2. All right, so now I'm going to square root both sides. So square root this and square root that. And when I square root both sides, I get x is equal to plus or minus, because remember when you square root something squared, it has to result in 2 answers. And then the square root of 1/2. So let's think about that for a second. The square root of 1/2, the square root of 1 is 1. The square root of 2 is not a perfect square, so I'm stuck here. But we can't leave a radical in the denominator, so I have to rationalize this. So my answer is positive or negative square root of 2 over positive 2. All right. So that is what sine x is equal to, positive or negative the square root of 2 over 2. Now, because we solved for x and we got a plus and a minus sign, then when I do my ASTC chart, I have to think about where is sign positive and where is sign negative, which means I should end up with 4 answers for this problem because it's in all 4 quadrants, because sine is positive in 2 of them and it's negative in 2 of them. So actually I'm going to have an answer for all 4 quadrants. And if you could see me, I'm talking with my hands, not that you can see my hands, so I don't know why I'm doing that. All right, so now, okay, so we take out our calculator again. We figured out which quadrants we're looking at. So our quadrants are all of them. So our quadrants are 1, 2, 3, and 4. Now let's figure out our reference angle. So our reference angle, we take out our calculator, and we are going to do second sine of the square root of 2 divided by 2. We should actually have known that because radical 2 over 2 is also part of our 1, 2, 3 and a 3, 2, 1 and all over 2 and square root the tops chart. Our reference angle is just 45 degrees. So let's think about that. If I need an angle of 45 degrees in every single quadrant, so in quadrant 1, In quadrant 1, my answer is 45 degrees because 45 degrees falls in quadrant 1. In quadrant 2, okay, remember I am falling short 45 degrees. So in quadrant 2, that would be 180 minus 45. So that answer is going to give me a 135 degree angle. So that's going to be 135. That's my answer for quadrant 2. All right, in quadrant 3, I'm going to be 180, but I'm going past it by 45 degrees. So that means I'm going to be adding 45 into this quadrant. You always base it off the x-axis. So that angle would be 180 plus 45, which is 225 degrees. And last but not least, in quadrant 4, remember again, you fall short of a full circle. So that's going to be 360, but minus 45 degrees. So that final answer will be 315 degrees. Those are my 4 answers. So if you want to be like super fancy about it, the angle measure, so in this case it was x, it wasn't theta. X could be 45, 135, 225, or 315. All of those would produce a positive or a negative radical 2 over 2. All right, let's step it up, make this a little bit more complicated. We are going to use a let statement again on this one. So let's let x equal tan theta. So if we let x represent tan theta, I'm going to replace tan squared with x squared plus 3x equals 4. Now that I have it in terms of x, I hope by this point, at this stage in your math careers, you recognize that this is a quadratic equation. And a quadratic equation, we know we want equal to 0. Fingers crossed that it factors. So let's get it equal to 0. So x squared, if my pen will write, x squared plus 3x minus 4 equals 0. It definitely is factorable, which is awesome for us. We're going to use the AM method factoring. So what multiplies to 4 but adds to 3, so x times x, 4 times 1. And because the 3 is positive, it's going to be plus minus. T-chart it up. I get x equals negative 4, x equals 1. But remember, x is representing tan, so this is really tan equals negative 4, and tan of theta equals 1. I need to squeeze a little theta in there. All right. Okay, so we have 2 different scenarios here that are going to produce 2 completely different numbers or values for theta, because negative 4 and positive 1 are not the same. So that means the angle that produces those values should not be the same. All right, so let's do one at a time. So let's think about this tan theta equals negative 4. Well, first of all, it's negative. The fact that it's negative, and I use my ASTC chart, I want to pick the quadrants where tan is negative. Tan is negative in quadrants 2 and 4. So the quadrants that is going to produce is quadrant 2 and quadrant 4. Now let's use our calculator to find what our reference angle is. So I'm going to take out my calculator. I'm going to do second tan negative 4, enter. Ignore that it comes out to be a negative value, okay? I'm not going to write down that my reference angle is negative. You are just going to ignore that negative, and you're going to say, okay, my reference angle is 75.963 ... We're not going to round anything just yet. So if I have angles, or a 75.963 angle in quadrant 2, okay, so to find that in quadrant 2, I do 180 minus the 75.963 yada yada yada. Okay, that's going to give me that angle. The other one, remember, is in quadrant 4. So that means I'm going to do 360 minus the 75.963 ... And that's going to give me the angle that matches in quadrant 4. So in your calculator, you would do 180 minus that answer. So 180 minus the answer. Oh, actually, let me do that, but then I got to go back and get rid of that negative. because we don't want that in there. Okay, answer. There we go. So our angle that would fall in quadrant 2 is 104 degrees, because remember, we're rounding to the nearest degree. So our answer in quadrant 2 would be 104. And our answer in quadrant 4, so you would do the exact same thing, 360 minus the 75 point yada yada yada, and you get 284 degrees. Now you might be thinking, all right, that wasn't too bad. Well, remember, that's half of the question. We also have tan equals positive 1. If tan equals positive 1, this is positive. And so if it's positive, we actually are going to be looking in quadrants 1 and 3 this time. So for this answer, we actually will have answers that fall in quadrants 1 and 3. All right, so let's figure out what our reference angle is. This one also is in our 1, 2, 3 and a 3, 2, 1 chart, but if you don't feel like making that chart every time, you just do inverse tan of 1. You get a reference angle of 45 degrees, which is beautiful. I don't have to do any rounding on that. And so quadrant 1 is 45 degrees, and in quadrant 3, remember, it's 180 plus 45, and that produces an angle of 225 degrees. So my final answers would be theta would equal 45, 104, 225, and 284. All right, 2 more examples left. But this one says secant. So this time when I do my let statement, let me use another color now that I'm doing back-to-back questions. I'll use green on this one. All right, so let x represent secant theta. All right, so if x is going to be secant theta, I have x squared minus 7x equals negative 12. Very similar to the last one. Let's get it equal to 0. Very similar to the last one. We're going to factor by AM method. What multiplies to 12 but adds to a 7 would be 4 times 3. But a negative 7 is both negative. So when I t-chart, I get x equals 4, x equals 3, and then go back and replace secant theta equals 4 and secant theta equals 3. Now, unfortunately, on my calculator, I don't have a secant button. I have sine, cosine, and tangent, and that's all I got. But we know a relationship, and I know it's been a while, but we know a relationship between secant and one of those. And if I say, which secant is the, inverse of which one, or the reciprocal of which one, not inverse, I'm sorry, reciprocal of which one, it would be cosine. So secant equals 4, then that means cosine is 1 over 4. And if secant equals 3, then that means cosine is equal to 1 over 3. So just like the one that we just did, just like number 4 where we had 2 separate answers, we have 2 separate, complete different answers on this one as well. So I'm going to set up my cases. What if cosine of theta equals 1/4? Well, it's positive. So I want to know what 2 quadrants is cosine positive in. Cosine is positive in quadrants 1 and 4. So my quadrants should be in 1 and 4. I'm going to use my calculator to determine my reference angle for those quadrants. So let's take out our calculator. We are going to do second cosine of 1/4. And I'm going to jot down a few of those decimal places, and I'm not going to round until the very, very end. So 75.52 ... 75.52 ... All right, I need those answers to be in quadrant 1 and quadrant 4. Well, in quadrant 1, if I'm rounding to the nearest degree, 75.52 ... would round to 76 degrees. So that's one of my answers. The other one would be 360 minus 75.52 ... and that would round 284. All right, so that's half the question. The other half is the cosine 1/3. So we pretty much repeat that whole process over again, but this time it's of 1/3. Again, 1/3 is positive. So we are going to be finding an angle in quadrants 1 and quadrant 4 that would satisfy that. And you know what? You can almost check, like, it's going to be slightly off. It'll be slightly off, but you can check your answers really quickly. Okay, so before I get too far into this question, if I do cosine of 284, now remember we rounded this answer, but in theory it should equal 1/4 or 0.25. That's pretty darn close. And the only reason why it's not exact is because, remember, it had decimal places and we rounded them. So you can check your answers really quickly. They're equal because we rounded. So it's kind of nice. So if you get these angle measures and it doesn't equal a positive 1/4 or approximately there, then you probably made a mistake somewhere along the way. All right, well, now we have to find the reference angle for 1/3. So inverse cosine of 1/3, pretty close to the last one. Our reference angle is 70.52 this time. Dot, 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 dot. We are in the same two quadrants as last time, so 70.52 dot, 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 and 360 minus that 70.52. And so my angles would be 71 degrees. And 360 minus that would give me 289. So those would be my values of theta that would satisfy the equations. 71, 76, 284, and 289. Alrighty then, last but not least, we're going to do one more of these. I know this is a slightly longer video than normal, but remember there's only 2 days in this unit, so. Find all of the solutions, but this time notice what your interval is in terms of. If your interval is in terms of pi, then your final answers have to be in terms of pi. So we're going to solve it, we're going to get everything in degrees, and then we'll convert to radians in the very end. So let's do as our let statement. Let me turn my color to maybe red this time. So let's let x represent sine of theta. So that means we have 2x squared plus x is equal to 1. Again, we have a quadratic on our hand, so let's get it equal to 0. And it appears that because we have a coefficient of 2 in front of the x squared, we have to use triangle method. So let's find our magic number, which is -2. So what multiplies to 2 but adds to a 1. So I'm going to split the middle, and I'm going to rewrite that as plus 2x minus 1x minus 1 equals 0. Group it, group it. Those two factors should match, so when I write it as my double bubbles, 2x minus 1 is one of my factors, and x plus 1 is my other factor. T-chart it up. One of my answers is 1/2, and my other answer is -1. Now remember, we didn't want to just solve for x. X is representing sine of theta. So we have to determine what value of theta would produce a positive 1/2 and what value of theta produces a -1. So I'm going to do the same thing I did on all the other ones. I'm going to kind of go over here and let's talk about it. It's positive. So where is sine positive? Sine is positive in 1 and 2. So the quadrants we're going to look at are 1 and 2. Let's figure out our reference angle. Okay, reference angle, you could use your 1, 2, 3, 3, 2, 1 chart because 1/2 is definitely one of the ones we know. But if you still don't have that down pat, you could do inverse sine 1/2. Reference angle is a beautiful 30 degrees. That makes our lives a lot easier because now 30 degrees in quadrant 1, 180 minus 30 is 150 degrees in quadrant 2. So if our theta is 30 and 150, we need to convert that into radians. 30 was one of the ones we at one point in time had memorized, but to convert to radians, you just multiply by pi over 180 and then reduce. So 30 over 180, and then you can math frac. So 30 over 180, math, enter, enter, and it'll reduce it for you. So if you already knew that, good job. Pi over 6. So one of my answers is pi over 6. So let's convert the other one. 150 times pi over 180, and then you can do math frac again if you don't know how to do it off the top of your head. 150 divided by 180, math, enter, enter, and it'll be 5 pi over 6. So there's my other answer. That's a 5. But that's only half the question. There was this whole other answer that we got over here. So sine theta equals -1. Okay, well, obviously it's negative, but if I just do sine inverse second sine of -1, that seems like a weird answer because it's not a fraction. So if I do that, oh, that's even weirder. We got -90 degrees. So actually, instead of using our calculator on this one, I think it's actually more beneficial to just draw yourself a sketch of what sine looks like. Remember, sine looks like an S. At 0, it's at 0. At 90, it's up at 1. At 180, it's at 0 again. At 270, it's at -1, and then by the time you get to 360 or 2 pi, you're back at 0. So the place where it's equal to -1 is actually 270 degrees, which is why it makes sense our calculator told us -90. Because if you go around a circle and you go -90 degrees, that spot is 270. So that means our theta equals 270 degrees. Well, what is 270 degrees, remember, converted into radians? So 270 times pi over 180, or maybe you have it memorized from our graphing unit, because we always labeled our axes the exact same way. That's 3 pi over 2. Because remember, we did pi over 2, pi, 3 pi over 2, which is 270, and then 2 pi. So 3 pi over 2 is our third and final answer for this question, 3 pi over 2, and all three of those would satisfy this equation. All right, so hopefully that was your crash course on solving trig equations, and you will do it again next year, but way more difficult. All right.